What we're going to look at today is more information that's available to you when you save data during an ASAP ray trace. This is the history type command, and what we see in front of us is a light pipe, and let me zoom in a little bit so we can see a little more. And we're simply tracing rays through the light pipe. The light pipe propagates using total internal reflection, so we'll also see some Fresnel effects at the end faces of the light pipe. And we know that if we, for example, issue a stats command in ASAP, we will see all of the surfaces that currently have rays or energy associated with them. In this particular case, the input and the output face have energy associated with them. Also, the body of the torus has some rays associated, and in this particular case, most of those represent rays that exited out the sides of the pipe due to frustrated TIR. But what we don't know is what the total flow of energy is through this light pipe. And actually, when we saved the information about this ray trace, that information was also stored. It's just we don't make a habit of telling people how they can access that data. So, for example, one thing commonly performed is a paths command. And since we know there are hundreds of ray paths through here, let's limit it to only those ray paths that have at least 0.1% of the energy. And if we do that, we can see that the grand total was 1,200 ray paths. What we can see here is that most of the rays bounced approximately 20 times before they exited back out of the light pipe. And in this particular case, object number 1 does represent the output face. But again, what we'd like to know is what is the flow of energy as the light travels through the light pipe. And actually that information is stored as part of the save command. And let me take a look here at the file so you can see what we've done. What we did was we issued the typical save command. In this particular case, we're calling the file that we're saving light pipe. Because I haven't added a file extension, it's going to be saved as lightpipe.his. It's a history file. And what's stored in this file is going to be information about the energy density as light propagates through the light pipe. There's no absorption going on. We're simply tracking the light or the energy as it goes through the light pipe. And again, since I've already run the file, let me open this here. And what we see is the light pipe itself, and we can sort of see the energy as well and the rays. And what I'm going to do is come over here, and as far as the geometry and the rays themselves, I'm going to temporarily hide them. So all we see now is this energy distribution. So this is giving us an idea of what the flow of energy is throughout the light pipe. We can also get an idea of the places within the light pipe that this frustrated TIR or leakage occurs. And again, this is the standard ASAP 3D graphics. So what I'm going to do is just select one of these slices and just move across it. So let's come over here. And I'm just going to slide this slice through one step at a time. And you can see it slightly changing. So now we're getting close to the body of the pipe, and we can see a relatively uniform distribution. This is the input end, so there's going to be more at the input and then a little less at the output. Again, we can just zoom across and get an idea of what that energy distribution is anywhere along that light pipe. And of course, we can move these planes in any direction. So we can, if I go up to the top, I can also move the plane down as well. So we can again get an idea of what the energy distribution is. This isn't absorbed energy. This is simply plotting and storing information about the paths of all of the rays as it travels through the system. And again, this is available to you anytime you issue a save command. All you need to do is bring that saved data back into the 3D viewer. And in this particular case, we've added that 3D view on top of a visualization of the geometry and the ray trace as well.